So I'm going to start by talking about electrical power. So or any kind of power is the amount of energy used per second. So in the case of electrical power, so first of all, it says power is the amount of energy used per second. It's measured in watts. And then in the case of electrical power, power is equal to current multiplied by voltage. So it's a combination of the current and the voltage together. So if we go back and look at our electrical circuits that we had here, this is the circuit I've got here. So my voltage is 12, and then my current is 0.6. So if I wanted to work out the power, it would be 12 times 0.6. So that's this series circuit here. If I was to look at this circuit here, this one, again, the voltage is 12, but this time the current is 2.4. So in this case, you can see I've got two lamps and they're much, much brighter than the two lamps in this circuit. So these two lamps here are quite dim. My current is 0.6. And in this case, I've still got one battery. It's still got a voltage of 12 volts, but here my two lamps are much brighter because my current is greater. So therefore, the power would be much greater in this circuit because it would be 12 multiplied by 2.4 instead of 12 multiplied by 0.6 as in this circuit. So in this circuit here, my two lamps are dim because they're low power, whereas in this circuit, my two lamps are bright because they're high power. So what would happen here is that the battery, if it was a real battery, it would go flat much, much quicker in this circuit because the power used is much greater than it is in this circuit. So power is current multiplied by voltage. So we can use that to help us work things out in various questions. So what I'm going to do now is I'm going to do a couple of sample questions so you can see what's going on. So I'm going to start with this question, which is a GCSE question. So it says, the photograph shows a converter heater designed for use in the home. It operates by air flowing through the heater and passing over the heating elements. It says the heater contains 3 identical heating elements and 2 switches. The student makes a model of the heater circuit using the circuit below. Power supply has a negligible internal resistance. Okay, so our circuit is like that, and it says the table gives 4 possible combinations of the 2 switches. Complete the table to show the total circuit resistance for each switch combination. So it's done the first one for us. It says A is open and B is closed. So if A is open and B is closed, that would mean the circuit would be like that. Okay, now because B is closed, we've got effectively a short circuit around this part round here. So the current is going to go this way. It's not going to go through here because here there is a resistance. This part is a wire, is effectively a short circuit. So the current is going to go around there like that. And as it says in the question, the only resistance in that circuit is this one here. So that's why it's written the resistance here is R. Okay, then if we look at A is open and B is open. So both of them are open like that. So now the current would need to go this way, like that, because that's the only way it can get from here around to here. Well, actually, the electrons would flow this way, wouldn't they, around there? But they would need to go through this resistor and then through this resistor. So in this case, the total resistance would be this resistor plus this resistor. They're in series, so it would be R and then plus R again. So here it would be 2R. Actually, let's rub that out first. So here would be 2R. Okay, then it says A is closed and B is also closed. So in that case, this would be closed and this would be closed. So we'd have possibility for the current to go around this way. We'd also have the possibility for the current to go around this way. So what we'd have here is effectively 2 resistors in parallel with each other, like that. Okay, now as I said before, it would be 1 over R total is 1 over R1 plus 1 over R2. Because those two are the same, you'd end up with the total resistance being R over 2, like that. Okay, that's rub out what we've got here. Okay, and then it says A closed and B open. So if A is closed, we'd have that possibility here. And then if B is open, we'd have that possibility here. So in this case, we'd have our circuit like this. And then there would effectively be 2R. So it would be a situation with parallel like that. Now in this case, I'm going to need, I think, to work out what that would be. So I'm going to do that down here. So it says 1 over RT would equal 1 over R and then plus 1 over 2R, because I've got R in this branch and I've got 2R in this branch. So that's why I've written 1 over R total is 1 over R plus 1 over 2R. So in this case, I would need to make the fractions so they're both over 2R. So I'd have, not 1, I'd have 2 over 2R plus 1 over 2R. So that would be 3 over 2R. So that's 1 over R total. So then when R total was worked out, it would be 2 over 3R. So this one would be 2R over 3. Okay, I'm going to rub all that out because I don't want that. That's just my working. And we can rub out this as well. Okay, so that's done that. So we've got R for the top, then 2R, then R over 2, then 2R over 3. So then it says, explain which switch combination dissipates the most energy in a given time. So as I was saying with the power earlier, the more power you'll use will be when the smallest resistance was. So in this case, we had here a small current, and because our voltage is the same, but our resistance is quite high, so our current is small. In this case, our voltage is the same, our current is much higher, so we'd have more power, so we dissipate more energy, and here our resistance is much smaller. So what we'd want for here would be where the smallest resistance is. So it would be when resistance is smallest, okay, so when the resistance is lowest, and then that would obviously be A closed and B closed. Okay, this combination here, because that gave us a resistance of R over 2, which was the lowest. Okay, and we've got the last part. It says the power supply is replaced by one with an internal resistance. Explain what effect this change would have on the thermal energy output of the heater. Okay, so if there's an internal resistance, what that's saying is effectively there's an extra resistance in here. So our battery would be all of that there. You wouldn't actually notice that resistance, but it's an internal resistance. It's part of the resistance of the battery. So because of that internal resistance there, what would happen is our supply voltage would be lower than it was previously. Therefore, our supply voltage would be lower. Our current would also be lower, and so the power usage would be lower across the board. So it says, right, power supply is replaced by one with an internal resistance. Explain what effect the change would have on the thermal energy output of the heater. So there would be a lower voltage, so less energy in all cases, so lower thermal output. Okay, that concludes the question. Okay, so this one I'm going to look at as a multiple choice question. It says an electrical circuit consists of 3 identical resistors of resistance R connected to a cell of EMF E and negligible internal resistance. What's the magnitude of the current in the cell? Okay, so what we're going to need to do here is first of all work out the equivalent of these 3 resistors. So those 2 that are in parallel here, these 2, they're both R and R. So resistance of those is going to be 1 over R plus 1 over R. It's going to end up being R over 2. So then I've got the situation where those 2 are the same as R over 2. And I've got the other one here of R. So the total thing is going to be the same as if the circuit was like that. And the resistance of this was 3 over 2R, because I've got R over 2 from this one, and then another R here. So it's the same as if it was 3R over 2. Then I can use that, what do I need here? The current. So V is equal to IR. So the current is going to be the voltage over the resistance. So the voltage, it says EMF is E, and then we're going to divide that by 3 over 2r. So the 2 would move to the top. So it's going to be 2e over 3, which is 3r, sorry. So the answer is B.